we're going to take the derivative of y equals square root of 2x all over square root of 2x plus 5. And notice that the x is under the radical, so we do need to take that into account. There's a couple different ways we can look at this. One is I could do square root of 2 times square root of x, or times x to the 1/2. If I put the whole thing to the 1/2, it's a chain rule, which is not a big deal, but I just want to show you another way to look at it. Square root of 2 times x to the 1/2 plus 5. So now when we go to take our derivative, this is going to be a quotient rule. So first off, we have the denominator being left alone, which is square root of 2 x to the 1/2 plus 5 times the derivative of the numerator. So the square root of 2 is just a constant, times the derivative of x to the 1/2, which is 1/2 x to the minus 1/2. It's just our power rule. Minus. Now we'll leave the numerator alone, so square root of 2 x to the 1/2 times the derivative of the denominator. And the derivative of the denominator, notice that this term is the same as in the numerator, so the derivative is going to be the same, which will be that square root of 2 times 1/2 x to the minus 1/2. And then the derivative of 5 by itself is 0. And there is our numerator. This goes all over square root of 2 x to the 1/2 plus 5, the quantity squared. Now, there's going to be some simplifying we can do, and it's going to come from doing a little bit of distributing. Now, one of the things we can do here is I see the 1/2 in both of these. I'm going to pull the 1/2 out front in the numerator to make things a little bit easier to work with. So now I don't have to worry about the 1/2 when I distribute. Now when I distribute, I'm going to have square root of 2x to the minus 1/2 times this term. So that will, let's put this all, write this all out. Square root of 2x to the 1/2. Then we distribute, which is going to multiply it by a square root of 2x to the minus 1/2. And then we'll also have that multiplied by the 5. So 5 times square root of 2 x to the minus 1/2. Here at the end, we've got minus square root of 2 x to the 1/2, square root of 2 x to the minus 1/2. All over rad 2 x to the 1/2 plus 5, the quantity squared. So let's clean up that numerator a bit. So square root of 2 times square root of 2 is 2. X to the 1/2 times x to the negative 1/2. Two things in the same base, their exponents add, so that would be x to the 0. So those are going to cancel each other out. Just like these are going to cancel each other out. Oh, and you know what? Let's put this numerator in a set of parentheses because of that 1/2 out front. So we have 1/2. Rad 2 times rad 2 is 4 plus 5 square root of 2 x to the minus 1/2 minus 4. All over square root of 2 x to the 1/2 plus 5, that whole quantity squared. We can see that the positive 4 and minus 4 are going to cancel each other out. So what do we have left? Well, this x to the minus 1/2 I'm going to put down in the denominator so that we turn that minus 1/2 into a positive 1/2. And then it's also going to turn back into a square root. So right now, and actually let's move that 2 to the denominator too. So we have 2 square root of x. So the 2 comes from the 1/2. The square root of x came from this term, moving to the denominator. Square root, I'm going to go ahead and make this square root of x again. And so that square root of 2x is going to look like it did in the beginning. Just changing back what we changed now that we don't need that for the derivatives. And what do I have left in the numerator? Well, this piece got moved to the denominator, and so did this. The only thing left is the 5 square root of 2. Now, one other step of simplifying that we could do, just to get everything looking very similar. Square root of 2 over 2 is actually the same thing as 1 over radical 2. Or this is 2 to the 1/2, this is 2 to the 1. We do our subtraction, we get a 2 to the negative 1/2, which is a 2 to the 1/2 in the denominator. So basically, these two kind of become a square root of 2. Now I can recombine that as well. So if I just want this to look a little bit more like it did originally, I could have 5 over square root of 2x times square root of 2x plus 5, the quantity squared.